In current video, we will talk about cryptography process, its types, and how it is used to ensure confidentiality of information. Cryptography process provides methods of storing and transmitting data in form that only those it is intended for can only read and process. Broadly speaking, cryptography is all about encrypting data using a specific or a set of keys and further decrypting data using same or different set of keys. So, overall, it is a science of writing secret code. Cryptography process ensures four basic goals by encrypting a message. Sender ensures it is a confidential as long as opponent did not have key or any shortcut to solve the puzzle. Cryptography makes information unintelligible to anyone who does not know or have proper key and measures to decrypt it. It can also ensure integrity of message in some manner, like if decryption produced some unusual message, it would be tampered in transit. Cryptography can enforce integrity with hashes or checksums, which is a one-way calculation from original message and is hard to duplicate or reverse engineer without knowing original text. We will go through details of hashing mechanism in other videos. Authentication is all about proving identity. So, if both sender and receiver had the same code book and exchanged element on it, it can be assumed that both parties are authenticated. Cryptography provides measures to ensure identity of parties communicating with each other. It also ensures non-repudiation in some manner. It provides methods to ensure that the originator is only one who knows the proper keys to encrypt or decrypt. Encryption is the act of scrambling plain text into ciphertext, while decryption provides vice versa process of converting scrambled text back into plain text. Encryption uses a known mathematical process or algorithm for performing its function. A cipher is an algorithm to encrypt or decrypt information. Algorithm must ensure that information once encrypted can be decrypted also. However, algorithm used to encrypt may or may not be same to decrypt it. Every cipher and plain text requires a key to encrypt. Encryption cipher uses cryptographic key to vary its output. By changing key, output of cryptographic function can be changed, even if plain text is same. Broadly speaking, we can divide cryptography in two types as symmetric and asymmetric based on how keys are used for an encryption and decryption process. Symmetric key or secret key cryptography uses a single key for both encryption and decryption process. Sender encrypts data using a pre-decided key and is transmitted down the wire to the intended receiver. Encrypted data is also commonly known as ciphertext. Receiver, on the other hand, decrypts ciphertext using same key as used by sender and get required data. Since key is unique and data can be obtained with help of specific key only, information is safe from getting revealed out. The first major symmetric algorithm developed for computers was Data Encryption Standard or DES, which is further replaced with Advanced Encryption Standards or AES, providing much higher bit keys. Symmetric key systems are simple and fast, but main drawback with these systems is distribution of key between sender and receiver. Key exchange requirement necessitates a high level of trust, as process of choosing and storing keys is difficult to achieve in a dependable and secure manner. Another disadvantage of symmetric key-based system is that there is no provision of data origin authentication and data integrity protection. Asymmetric key or public key cryptography, as name suggests, requires two separate keys. One key for encryption while another for decryption. Here, both keys are mathematically aligned such that data encrypted by one type of key can only be decrypted by another key. Usually, One key is called as public key and is publicly available, while another key is called as private, which is never distributed and is kept privately to encrypt data. In usual operation, sender encrypts data using public key of receiver and sends ciphertext down the wire. Receiver, on the other hand, decrypts ciphertext using its unique corresponding private key. Since data encrypted by public key can only be decrypted by corresponding private key, which is never distributed, this makes information safe from leaking out. Asymmetric key cryptography solves problem of key distribution, but its main drawback is large size of ciphertext with respect to that obtained in symmetric key cryptography. Public key infrastructure, commonly known as PKI, provides an infrastructure required to create, manage, redistribute, use, store, and revoke set of asymmetric keys. We will be discussing more on PKI in another videos. Encryption makes data unreadable to anyone, except for authorized person with right software and keys. If data is valuable, attackers will try to break code either by analyzing ciphertext or by finding the key. In ciphertext only attack or COA, attacker has access to segments of encrypted data or ciphertext, but not the plain text associated with it. This type of attack is most common but is also most difficult due to lack of information present. Similarly, in known plain text attack or KPA, attacker gets access to certain pieces of information before and after encryption. Here, segment of plain text and corresponding ciphertext is available and attacker try to guess key for same. In chosen plain text attack, attacker somehow get access to part of plain text. He encrypts this random information and observe the output. Here, attacker matches with that of original ciphertext and try to guess key used for original encryption. Similarly, in chosen ciphertext attack, attackers somehow get access to some part of decryption machinery. He selects some part of ciphertext string and try to guess corresponding plain text string. So here we finish our video on cryptography and have discussed its importance and its different methods. Now let's quickly summarize all concepts discussed in this video. Cryptography provides methods of storing and transmitting data in a format understandable only by target or intended person. It helps in ensuring confidentiality, integrity, authentication, and non-repudiation in IT system. Encryption is the act of scrambling plain text into ciphertext, while decryption is a vice versa process of converting scrambled text back into plain text. Symmetric key cryptography make use of a single key for both encryption and decryption process. Asymmetric key cryptography make use of mathematically aligned by separate keys for encryption and decryption process.